let n be a positive integer such that 100 choose n is greater than n choose 10. And we want to find the sum of all possible values of n. So with our note, that if the top number in the binomial is greater than the bottom, or if the top number is less than the bottom, then the value of the binomial is 0. So that means that in order for 100 choose n to be greater than the n choose 10, then that means that n has to be less than or equal to 100. And n is also positive, so n is greater than 0. So from here, we can break it into 3 cases. So the first case is n is less than 10, then we have between 10 and 90, and then from 90 to 100. So let's go case by case. So in the first case, if n is less than 10, then that means that n choose 10 is equal to 0, since the bottom number of the binomial is going to be greater than the top. Well, since 100 choose n is going to be positive, this means that any value less than 10 will work. So far we have, if s is the sum of all possible values of n, s is 1 plus 2 plus so on to 9. In the next case, we have n is between 10 and 90 inclusive. So we note that 100 choose n is greater than or equal to 100 choose 10. If we imagine Pascal's triangle, 100 choose n is going to be closer to the center, so it will be of a greater value since it's in the same row as 100 choose 10. And that is going to be greater than n choose 10. So that means that 100 choose n is always going to be greater than n choose 10 when n is in this range. So far we have s is equal to 1 plus 2 all the way to 90. Finally, we have the last case where n is greater than 90. So in this case, we notice that as n increases, 100 choose n will decrease, since if we think about Pascal's triangle again, 100 choose n is going to be going farther away from the center. So that means that it will be decreasing. On the other hand, n choose 10 is going to be increasing, since the top number of the binomial is going to be increasing, but the bottom number is constant. So that means that we can test n equals 91 to see if that works. So 100 choose 91 is exactly what's on the screen, and 91 choose 10 likewise. So now we want to see which one is bigger. So we're asking, is 100 choose 91 greater than 91 choose 10? And another way to ask this is this fraction, which is the ratio, greater than 1? So if we expand both of the binomials, we get these fractions. And then we can substitute that to get that. We want to compare this crazy fraction and see if it's greater than or less than 1. So we can simplify that since both of the top fraction and the bottom fraction has a 1 over 9 factorial. So we're asking if this fraction is greater than 1. Well, that's equivalent to asking is if we move the 82 over 10 to the right side, then we have this another fraction, which is easier to, which is lighter to compare. And we'll notice that the fraction on the left has 9 terms in the numerator and 9 terms in the denominator, each of which are 9 consecutive integers. And we can also break this product into the product of 9 different fractions, specifically that 100 over 91, 99 over 90, and so on. And we'll notice that each of these is increasing, but they're all less than 10 over 9. So for example, 100 over 91 is less than 90 over 81, since they're both 9 over the denominator plus 1. And 90 over 81 is equal to 10 over 9. So then the left-hand side is less than or equal to 10 over 9 to the 9th. But 10 over 9 to the third is equal to 1,000 to the 729, 1,000 over 729, which is less than 1,000 over 700, which is 10 over 7. So 10 over 9 to the 9th is less than 10 over 7 to the third. And 10 over 7 to the third we can compute as 1,000 over 343, which is less than 3. But on the right side, we have 82 over 10, which is greater than 8. So that means that our fraction is not greater than 82 over 10. So our answer to all of our questions is no. So 100 choose 91 is also not greater than 91 choose 10. So 91 is not going to be in our sum for S. Well, if we remember that as n increases, the 100 choose n decreases, but n choose 10 increases. So none of the values greater than 91 are going to work either. So that means that S is simply just 1 plus 2 plus so on until 90. And that's the sum of the first 90 positive integers. So that's 90 times 91 over 2, which is 4095. That is our final answer.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.